Greetings, family, friends, and survivors. Well, sorry about the rapid succession of videos, but this is kind of how it's going. I get a few minutes and I come up here and dig through all the tools and see what else I can do with the parts that I have. And started working on the cooling loop. And let me explain about the cooling loop. The cooling is not to put out a fire. Controlling the temperature of the batteries is going to give you the most longevity out of your lithium ion. And since I have a fairly hot room up here during the summer, I thought it would be good to keep the batteries cool. I tried very hard to keep the lead acid cool, and this was fairly straightforward to be able to do that. No, the cooling will not put out a thermal runaway fire with 18650s, but you're less likely to have a problem if you're operating not only with the right voltage parameters, but also not with excessive or minimal temperatures. So this is a heating cooling system, and I've got it set up. I don't have any glycol to put in it yet to test the cooling side, but I'll explain it to you. Right now there's just 3 batteries installed, and this is the tubing going through the cooling loop, and this is the controller, and it's got an outlet up here for the heating and an outlet here for the cooling, and there's a high temperature circulation pump here. Of course, we'll never see high temps, but I got one that was rated for a circulation pump for a hot water system. I figured it would last longer if it was able to handle some temperature. I think $9 on Amazon for one of these overflow bottles for a radiator. And so this is the suction side. Discharge through the batteries, comes back out and goes through the wall right there. And this is temporary. Didn't have time to figure out how I'm going to put it outside, and I've got valving and that sort of thing to work out, where there's a bypass valve so that the heating element is heating the glycol circulated through the reservoir, bypassing the radiator. But in the summertime, it goes through the radiator. Well, this glass comes out, and once that is a door right here, it's going to cut the temperature in this room in half. So what you see is a little radiator there, and it's got room to add one more fan. And I wanted to make sure the fans that I got were the right ones that lined up with the holes, and they do. So I'll get another fan for that. And I may at some point plumb it outside so I can blow colder air through it, maybe on the shady side of this building, but I really think once that door's in, it'll be fine. So the heating side, the parameters are already set with this for heating and cooling, but I don't have the heating element. I need to drill a hole in this and drop an aquarium, a 30-watt aquarium heater in here, and that'll just plug in that outlet right there. And then right here between these two have a bypass valve where it bypasses the radiator and just circulates what's in the pump or in the reservoir. And that should work pretty good. It was so inexpensive to do it. I think the controller and the reservoir and the pump and the radiator and the fan, I think all of that was $130, and that'll ensure that my batteries are operating in a controlled environment. So I thought, since that's how they were designed in the car, there must be a reason for that. So if we can keep them in the smallest temperature swing that we can, the narrowest bandwidth that we can, then they ought to last longer. So everybody's been telling me that you don't have to worry about heating. You're going to throw all the amps you got on those and they're not going to heat up in this application. That's probably true. So heat really isn't the issue. The real issue is it gets cold here. And this is a very insulated room. And when you use batteries, they naturally make heat. And this equipment makes heat. And more than likely, the heater element will never come on. But if I was on vacation, the batteries weren't being used very much, and it got really cold, if you charge those batteries below 32 degrees Fahrenheit, you've got serious trouble. Well, that aquarium heater and that controller have taken care of that issue completely. So even if it drops down to around 0 or a little bit below outside, I've seen this room in here as low as 19 degrees. However, today, yeah, it's hot enough it's difficult to think straight. Let's put it that way. So I thought I'd play with the cooling system since I'm waiting on the termination for the cabling. That's really all I've got left to do is make the cables and termination lugs here and move the positive and negative bus work in here and move the shunt over to this wall and then bring it up very slowly. And I'm hoping to make the change over where I do it quick enough that the capacitors in the inverter are already charged. One of the problems that you can see is there's so much current available with lithium ion. If you've got an inverter that has discharged its own capacitors, it can be a sizable arc. The inrush current coming into the caps with lithium ion is actually fascinating, if not dangerous at times. So, in fact, a lot of people do it through resistors by steps when they're hooking large lithium ion up to a brand new inverter. But I think if I switch it over within 10 minutes, the self-discharge on the capacitors is not going to be an issue. They're already going to be full when I turn the switch on. So I don't think that's going to be an issue. The reason why I have 3 BMSs, these are not balance boards. These are not battery monitoring. These are battery management. And the difference is, rather than just balancing, if all I was going to do was balance, I could parallel all 3 batteries and run balance leads to them and balance all 3 of them at the same time with a balancer. But that wouldn't protect the batteries from overvolt and undervolt. So each of these guys have a overvoltage disconnect and an undervoltage disconnect, as well as live balancing, full-time balancing. And they're rated at 100 amp continuous, and I think they're 200 amp for a few seconds, and they'll never see 100 amps continuous, but I wanted to get some that were big enough that they could handle. So the one could actually go offline if one got out of spec, one battery, and it was having an issue. That one BMS could drop that battery out of the circuit, and then of course I'll get an alarm telling me that there's an issue. So I think it was the right way to go by getting a BMS, 100 amp power handling BMS for each battery module. So the next step is, I've already taken the leads that come out, the balance leads and the ground, and I've extended them. They're soldered, and the heat shrink is all done. And now I don't have my glasses on, but these bottom right here, I think the ground is on the right, and then all of your taps for your different voltages are from right to left on these guys, and they're all typical. So coming in and terminating these to the balance lead is the next step, and then all the cabling, and then make sure all 3 batteries are the same voltage, and right now they are, and then parallel them and then go ahead and see if they want to take some power and how that works out. And I've got all 3 charge controllers to reset all the parameters on. And I've talked to friends that are using lithium ion with these 2 different guys. I haven't talked to anybody that's using the Outback with lithium ion, but I did read the publication from Outback and it seems pretty straightforward. They're going to redesign the software. I think TriStar already has redesigned software for lithium specific, and there may be some firmware that they'll write at some point that I'll be able to download and give these guys a new identity. But so far, nothing's available from the factory other than kind of a stopgap measure and adjusting the parameters with the equipment as it sits. So I think that's going to work pretty good. I'll discuss a little bit more later once I bring them up and start charging, and share with you what I've learned about these 3 completely different brands in charging lithium ion. So it should be interesting. I'm considering putting a fireboard behind that back wall. Frank Z said, hey, why don't you throw a piece of what does he say, a sheetrock back there? I think I've got some fiberboard. I probably will do that. That makes sense. Those guys probably could get fairly warm. Although they're on offsets right now, it just might as well. Since they came from overseas, I think it's a Taiwan company. It's a reputable company for the electric vehicle industry, and that's what those are actually designed for. They're designed for the electric vehicles. And I think they were running I think about, if I remember, 3 to 5 kilowatt packs per BMS, and so a car might have a dozen of those things, and they're cheap enough. Most expensive one they make, the 200 amp, is just shy of 200 bucks, something like that. So I'll let you know how those work. Anyway, it's too hot to think. That's why I'm rambling. Have a blessed day.